radicals and simplifying them before. And that meant converting them into mixed radicals, like trying to get a coefficient. We're going to go the other direction now. Okay, so we're going to take mixed radicals and turn them into entire radicals. It's not a very practical thing to do. Okay, so you'll notice in like Math 20, Math 30, we don't do this very often. It doesn't have a lot of applications. Going the other direction does have a lot of applications to it in the future. So this we don't do a whole whack of. Unfortunately, it's pretty easy, so you probably like wish we could have done it. Right? Just the way the cookie crumbles. They do a question for you, and they break it down in a different way. I find like this is a good tool if you don't understand the way that I do it, but I do it a different way because it seems to be what you guys learn better with. Okay, so what we're going to do is just jump straight to the examples. We got 6 of them here. We need to convert these mixed radicals to entire radicals. So it says mixed radicals to entire radicals. Awesome. That means we don't want a coefficient anymore, right? These questions all have coefficients, 2, 4, and 10. We need to get rid of those coefficients. The best way to get rid of those coefficients is to get it underneath the radical sign. So what I do is I say, okay, let's take this coefficient and let's move it under the radical sign. When I move it under the radical sign, we multiply, right? That's what coefficients do, they multiply. So this is going to become 5 times bracket 2. Now, it doesn't make sense that you could just move something under a radical sign without doing something to balance it out, right? You'll notice in math, we balance all the time. We always say what you do to one side, you do to the other. Right? What you do to the top, you do to the bottom. Right? Math is all about balancing and equal signs. So if I move something in math, I have to balance it somehow. If I move this coefficient underneath the root sign and I'm square rooting it now, then I need to square that thing when I move it. So it becomes 2 to the power of 2. That's underneath the radical sign. The way this looks now, I'm just going to write it a little nicer for us. So it looks like this. 5 times 2 squared. All right, so when I moved it, I squared it, and I multiplied it to the old radical. This thing, this is my new radicand. I need to calculate it. I don't put the square part, right? I just want to calculate my new radicand value. So all I'm putting in my calculator is 5 times 2 squared. That gives me my new radicand value of 20. My final answer is square root of 20. Not that bad, right? Take the coefficient, move it underneath the radical sign, multiply it by the old radicand. Okay, let's do another one together. So I got 4 times the square root of 7. That has a coefficient. They want us to make it an entire radical. That means get rid of the coefficient. So I need to take my coefficient and move it underneath the radical sign. When I move it under the radical sign, I multiply it by the old radical and I square it. That means I now have the square root of 7 times 4 squared. This part underneath is my new radicand. It needs to be calculated. Right, but I'm just doing the radicand part. I don't do the whole radical. When I put that in my calculator, we have 7 times 4 squared, which I don't know what it is. Anybody calculate it? 120? 12. Oh, 20, that's surprising. And now I'm writing 20 because I said it out loud. 112. That's now an entire radical because the coefficient's gone. I told you this part was easier. Yeah, that's not bad. Okay, the very last one. So we have a coefficient. We want to become an entire radical. That means we need to get rid of the coefficient. To get rid of it, we need to move it underneath the radical sign. When we move it, we multiply it. So it looks like that. We also square it because it's a square root. Just writing this a little neater, that means I have the square root of 6 times 10 squared. This part can be calculated. When I calculate it, I get square root of 600. Not bad. Awesome. We're going to do 3 more examples. They're going to be a little bit harder. The only reason they're harder is there's negatives, there's decimals, and there's fractions. We're just going to talk about how we handle all 3 of those things. Awesome. We'll start off with the fraction. The beautiful thing about converting to entire radicals, I'm just going to scroll up. I see a few people who looked up to see if they could finish writing that down. The beautiful part about fractions and decimals and converting into entire radicals is nothing changes. We're still going to follow the exact same steps. So in this case, my coefficient is 3 divided by 2. It's just a little bit more complex to put in my calculator. That's all that happens, but it's still the exact same process. I don't want a coefficient, so I need to move the coefficient. I move the coefficient by multiplying it underneath here. When I do that, make sure you put brackets, okay? So it's going to be bracket 3 divided by 2, bracket, and then square. Just writing that a little bit nicer for you, that means you have square root of 8 times 3 divided by 2 squared. Right, nothing has changed. I still follow the same process. Coefficient under the radical sign, square. When you put in your calculator, just be a little bit careful. To put fractions in your calculator, you must put brackets. So you have to go 8 times bracket, 3 divided by 2 bracket, and then square. Right? If you don't put the bracket, what your calculator thinks you want to do is it thinks you want to do 3 divided by 2 squared, and it's only going to square the 2. And that's why the brackets matter, because the 3 and the 2 are both being squared. When you do that, you should get 18 as your radicand value. Is that what we got? Ooh, yes? Some people are nodding yes. Let me check in my calculator. That mental math was a little bit scary. And then we're going to times it by 8. Yeah, 18. If you're not getting 18, try to do it in chunks. Okay, so do just the fraction squared. So go bracket 3 divided by 2, bracket squared. That'll give you 2.25. And then multiply 2.25 by 8. And then that's just breaking it into chunks so that your calculator doesn't make some weird mistake on you. But your answer should have been square root 18. Fantastic. The next one is a decimal. We're going to follow the exact same steps. But you have a coefficient, you don't want a coefficient, so you're going to take it and move it underneath the radicals. When you move it, you have to square it. When you do that, you end up with 50 times 0.4 squared. You're going to do the exact same thing, okay? 0.4 squared, figure out what that new decimal is, times it by 50, you'll 0.4 squared times 50, and you get 8. This thing turns into square root 8. The last one is the only one that has a trick to it, okay? The reason it has a trick to it is because of this negative symbol right here. The negative on the coefficient. If you have an even root, so that means the index is an even number, then the negative can't come underneath. The reason it can't be underneath is if you have a negative number squared, so for instance, negative 5 times negative 5, right? Negative 5 squared. It's going to turn it into a positive because a negative times a negative is a positive. That means you'd be changing this entire question into a positive answer. And we know that this is a negative number because there's a negative out front. And when we simplify things and we convert them, we don't actually change the value of the radical if you were to calculate it. By taking this negative underneath, it would be destroying the negative essentially, and it would be changing the value of the radical. So with even indexes, the negative stays out front. Maybe the best thing is that you guys have already learned a rule about root signs, and it's that you can't square root negative numbers. Maybe you've heard that a long time ago. If you haven't heard that, the reason you can't square root negative numbers is remember that square rooting is breaking something perfectly in half, right? So it's two things that are the same that multiply to be that. If I'm multiplying to become a negative, then I have a negative number and a positive number, right? It's the only way I can multiply to be a negative. So that means I could never square root and get the same number twice. That would multiply to be my original thing. Right? Because I would always need one to be negative, one to be positive. It means they're not the same thing anymore. Kind of tricky, right? That's why it's a little bit tricky. The best way to look at it is negative, even index, only the 5 is going to come inside. The negative is going to stay outside. That means I have negative root 7 times 5 squared. You're going to calculate your new radicand value. You have negative root. Change this. I think it's 175. And that would be your final answer. Negative square root 175. Awesome. Your quiz